Okay, class, we're going over the homework here, and Hannah has a really good explanation for the graphical approach to limits, and so we're doing a little bit of homework review. And Hannah has a real good explanation for this. She's going to explain this second problem here. Here we have this graph. She's going to explain what's going on. Go ahead. Yeah, go ahead. Go. Okay, so you can go ahead.
Okay.
Microphone.
So this is how I do it. I look at the one from the left side, since this one's negative, approaching from the left side. I see what this is, the y is 3. And then from the right side, it's approaching from the positive side, and that is 0. Yes. And then this, that since they're not equal, then this does not exist. Because they have to be equal. And then this is whatever this is, so it's going to be 3. Whatever the filled in circle is.
The only numbers that we write down are going to be from the left.
Is the bottom one going up or is it going out? Just one
The bottom one?
Yeah.
What do you mean by the bottom one?
The one on the
This
right.
one here, or this one?
Yeah, that one.
Yeah, the thing is coming back, the thing, if you talk about it in terms of domain and left to right, it's actually decreasing, but in limits, in this case, a right side limit, you're actually coming from the right to the left, which is kind of a weird thing, right? Because what have you been doing in your mathematics career? You've been going left to right, which you do for your left side limit that Hannah got here, but the right side limit, you have to come this way. And so that's right.
I didn't understand that one. I thought it was going the other way.
What, this one?
Yeah.
Yeah, the graph is, if you graph it like from left to right, it would graph like this. But when you get a limit, you got to come from both sides. And so you're coming from both sides. And remember I told you to consider a fence? Like if there's a fence right here, these two people are coming to meet each other across the fence. Do they meet each other across that fence? No, they don't. Limit does not exist. Okay, so that's really that one. So
That fence thing, that made sense.
the fence does.
Yeah.
Yeah. So you can think it. One thing you can do if that makes more sense to you, you can go ahead and like draw a fence. You say, okay, here's the fence. Nope, they don't meet at the fence. Limit does not exist.
Now that makes sense.
Yeah, that's a graphical explanation. Now the analytical explanation is that this is not equal to this. To me, I like this graphical explanation because you can see it, right? But the analytical form is this one right here. So that's that. And so this one right here, so it says at 3, right? So here's our fence. Let's draw our fence right here at x equals 3. And so does it, from the left and from the right, are we meeting each other across that fence here?
So is it going to be 1, 1,
1, 1, 1,
Is there
1,
a DNA?
1.
Yeah. If there's a hole where that is.
Yeah,
Like if you look at
There's a
the
hole
formula,
right there.
D would be D and E because there's
yeah.
there's a hole and there's not another solid point.
Okay.
Like number 5, D would be D and E because there's a hole and not a solid point. But if there's a solid point, would it be?
Yeah, like number 6,
Whatever
there's
the solid
a,
point is.
number 6, there's a random solid point, and that's what D is.
Yeah, and then we get to number 4. Number 4 is what? 12.5, 12.5, 12.5. Yeah, and it's really not, it might be look like 13 or something like that too, right? But that's also here 12.5, isn't it? Doesn't really say exactly, it looks like it's about 12.5 or thereabouts.
Mr. G, may I have a request?
What is your request? Let me a little more light. It's dark out there, so it's not going to mess up my... Because usually I don't want to have the sun, the light pollution because of this up here.
It
But
makes me
it's
feel
a-
like I'm not in a jail cell.
Yeah, but it's a dark day today. But usually it's sunny, and I gotta have these things down when it's sunny because of this mainly, right? But yeah, for today, yes. Okay, this one here, for this one here, what'd you get for this one here? As we approach -1, so 0, 0, 0, does not exist.
Okay, so wait, why didn't we put 0.5 instead? Or is it just because there's a...
Yeah, it's where the hole is.
Yeah, it's a good point. It's where the hole is if it was filled in, right? Yeah, good point. Because what happens is, in this instance, you have, even though the thing doesn't exist, there's a location where it doesn't exist, which is the limit. Okay, this one over here, 6, we have, for 6 we have 1, 1, 1, 0. You may not be able to see it on yours, but there's a hole here and there's a filled in down here.
Is that red? My face
Okay, and so that brings us, okay, so what you can do is you can turn in your homework assignment. I know we covered it all, but I want to tell you in the future about homework assignments is homework is one of those assignments. If you do the homework assignment, it's a participation grade essentially. Did you do the homework assignment? You're not, to me, I'm not asking you to guarantee me, or I'm not checking 100% to make sure everything is right on that. I want you to make it as right as you can be. But remember we went over that problem yesterday with the PEMDAS problem? Remember that? And what did I say? I said you shouldn't be afraid to what? So make a mistake or get it wrong, exactly. What happened is I heard back from all my Facebook friends, they all thanked me. They all thanked me for it. So we did this, right?
Oh, it's torn for it.
So we already did this once. We're going to go on.
We're on number 7, I think.
Yeah, so we're going to go here to, yeah, so we finished with this yesterday, didn't we?
Yes.
Is that kind of where we left off?
Yeah.
Okay. So it says, now we go over the process here. And can you see this on your paper okay? Okay. So we have example 1, find the limit as x approaches, that looks like -2, isn't it? Of this, and you can do this by plugging in. So this is going to be equal to, we put in -2 squared minus 4 times -2 plus 1. And what is this going to be? Yes, well, the one that I gave you. Oh, this one, did you do this one yet? Turn it in yet? Okay. No, I gave credit for it. Here, mistake, put this in line. What is this gonna be here? That's what I get 13 on this, okay?
Oh, I was thinking that was, yeah.
And whenever you see something like this, a limit, and you just have a polynomial expression like this, you know you're going to get a value. You're not going to have anything more work. You're going to get a number for an answer, and that'll be it. You put it in the calculator, didn't get 13?
Should have put it in the calculator, didn't it? Yeah.
You ever seen how we got 13?
Negative 2 times negative 2 plus 5.
This is 4
Negative
plus 8 plus 1.
Yeah, makes sense.
Okay, 4 plus 8 plus 1. And then also, if we get to example 2, and for example 2, we're plugging in negative 2
The other day you told us that we're supposed to, like, I know negative 4, but you would say, the other day you said negative 4 minus 4 times 2.
You have to do the most.
okay, are we okay now?
Are you saying like multiply by 4 times 1 and then multiply by 2?
I think just like subtract, just do the 4 minus 4 and then
Okay, ready to look at example 2 now? Okay, so here we're also approaching negative x, that approaches negative 2. So we plug in first, so we have 2 times negative 2 minus 6. And then over here we have negative 2 minus 2. So we have, that's what we have. So what is this going to be? So negative 4 minus 6, and then we have negative 2 minus 2. So that's going to be negative 4, is that right? And so we have negative 10 over negative 4, and that's going to be 5 halves, right? So 5 halves. Do we have more work to do on this one? No. So we are done with this one.
we only have more work when it's 0, 0, right?
Yes. The question was, do we have only more work to do when you have 0, 0? The answer to that question is yes. Okay, so now we have a different setup here, where if we plug in negative 2, we get negative 2 squared minus 2 times negative 2 minus 8 over, we have negative 2 squared minus 4. So what is this going to be here?
The bottom is going to be 0.
Bottom will be 0, and the top will be 0, right? Because you have 4 plus 4 minus 8, 0. So you have, like I was saying the other day, you have more work. I think it's kind of cute. More work. Okay, so more work. So let's do the more work here. So let's go ahead. So we know that the thing's going to be factorable in some way, shape, or form. So let's factor these guys here. And so what do we have when we factor these? To me, the bottom one's easier to factor. X minus 2, x plus 2, right?
Yes.
What is the top one factor? So x minus 4, x plus 2. So let's go, let's check that. So that's going to be negative 4x plus 2x. Yeah, so I think this is right. So what cancels out here? That, right? So now we can plug in, what, negative 2. So we're going to get negative 2 minus 4 over negative 2 minus 2. And what's that going to be?
Negative 6 over 4, so 3 over 2.
So 3 over 2. So here's an example where that happened and we got 3 over 2. All right? And now what we have here is we got a situation where this one, example 4, we have x squared minus 2x plus 1 over x cubed minus 1. So here we get, if you plug in 1, do you see we're going to get 0 over 0?
Yes.
Yeah, we do. But this one here is factoring a difference of cubes, which is one that we didn't work on too much in pre-calculus or even in algebra 2, did we? But let's go ahead and do this anyway and see if we can figure that one out.
Is one going to be just the x plus or minus something, and then the other one's going to be x squared plus or minus something?
Okay, let's go ahead. This numerator, can we factor this? X minus 1 like this. Does that look good? Okay, and we know that this one right here, now there's a difference of cubes, and if you forget what it is or haven't done it, how can you figure out what we have left? So 1. So we're gonna go ahead and synthetically divide this. So we put 1, 0, 0, 1. Remember this? Right. Let's bring down the first one. So we know we're going to have, I put x there, I meant to put 1. And then what 1 times 1 is? 1. 0 plus 1 is? 1. 1 times 1 is? 1. 0 plus 1 is? 1. And 1 times 1 is? 1.
2.
And so we have 2. This is somehow not coming out right. There's something that's messed up here. Oh, I know what it is. This is supposed to be negative 1.
Yeah.
See that? That's where the mistake was.
0.
0. So now what is this here?
X
This
squared.
one's cube.
So you have x minus 1. So you have x squared plus x plus 1. And so that's what it is. Can we cancel now? Yeah. And so somehow, okay, if we go to x minus 1, yeah, that's going to be good. So now if we plug in here, if we plug in 1, what do we get? 0 over, we plug in 1 down here, what do we get?
3.
0 over 3, which equals 0. So our answer to this one here is 0. Does that make sense? Now this is a factoring that was a little more involved because of this cube thing. And there is a difference of cubes that could, if you know the rules, it could work this out. So, yes.
Sure, even if we take a picture of you real fast.
Okay, well, it's your camera at risk.
Is this for you?
You should have got.
I am Mr. G.
You should have got Hannah up here teaching the class. You should have got Hannah teaching, because Hannah was doing a great job.
Smile. Okay.
I'm holding it. Do you have
Thank you. You should have got Hannah teaching. That's what you missed. Hannah did great. She was, speaking of Riley, Riley sort of has a new role on the volleyball team, doesn't she? Kind of a hitter.
She's all around.
She's kind of all around.
Okay, so,
It's
quick
cool.
question. So if the 0 is on top, then you get a 0, but if 0 is on bottom, you get undefined, correct?
Exactly.
Okay.
Yeah, zeros, if it's only 0 on top, but 0 over 0 is more work. Okay, so that's good. That's a good thing. Now here, they show an example. They say, here's example 5, and in limit as x approaches 2 of 2x plus 5 over x minus 2, you plug in and you get 2x. If you plug in, you get 9 over 0. Well, 9 over 0 is, you actually have, you really can't factor, you've actually solved it. So your answer is, in this case, does not exist. Okay, so it has to be 0 over 0 to have more work, right? Other than that, if it's 0 on top, it's just 0. If it's just 0 on bottom, it's undefined, does not exist. So that's what it looks like. Okay, so now we have some other examples right here. If you have the limit as x approaches 0 of 4 over x squared, and you plug in 0, so you get here, does not exist. Okay? And I want you to go ahead and go ahead and work out problem number 7, example 7. We'll go over that in just a minute. The bias is going to be on tests and so forth and quizzes that usually you're going to be given a more work situation. Not always, but more often than not, you'll probably get, because the problem makes more sense if it's 0 over 0, doesn't it? That's what you'll notice. I got this note on my door, you see that? Strive for growth, not perfection. I don't know if to put it up there, but
It's Lady and Madeline.
Laney and Madeline,
They're writing those ones.
are they? Okay.
Supposedly.
Okay, well, they will be, I'll ask them about it today. So how are you coming on number 7? Pretty well? Okay, number 7. If we plug in -3, what do we get? Do we get 0 over 0? So -3, I'll put -3 squared plus 2 times -3 minus 3. And then we have -3 squared plus 6 times -3 plus 9. So to me that looks like 9 minus 9 minus 3, so that's 0, isn't it? And then on the bottom we have 9 minus 18 plus 9, that's 0, isn't it? So now we factor that out. What do we have? We factor these guys out.
Your top is x plus 3, x minus 1.
X minus 1, okay.
Bottom is x plus 3, x plus 3.
X plus 3, X plus 3.
So they cancel the x.
So are these pretty easy to factor right here?
When they're like this, they're easy to factor.
Yeah, you should be able to factor every quadratic thing pretty easy, and also greatest common factor things. So this is what we have here. So now we're going to plug in. So we get negative 3 minus 1 over negative 3 plus 3, which is going to be negative 4 over 0. So what about this one? Does not exist. So limit does not exist in this case. Did everybody get that? Okay. Usually you end up getting a number on those, but not always. Just have to see what you get. Now, example 9 is, what did we call this kind of function here yesterday? Yes, okay, somebody said it over here. We call it a piecewise function. Piecewise function. And what we're doing is, it says find the limit as x approaches 1 of f of x. And so you have this one right here is going to give us, the one on top is going to give us which limit for x is greater than or equal to 1. What limit is this? Or what side limit? So this one's going to, x, so x squared minus 4 when x is greater than or equal to 1. So which limit, which side is that? For x is greater than or equal to 1.
Or the right hand.
That's our right side limit, right? So here's our right side limit. So that's going to determine our right side limit. And what is this bottom one going to be?
Left side.
Left side. So left side, left side. So, and if we plug in 1, right? So we put in our left side limit, so we have negative 2 times 1 minus 1, and that's our left side limit. And our right side limit is going to be, we have 1 squared minus 4. So what is this on the left side? What's our left side limit? Negative 3. And what's our right side limit? Negative 3. So what is our answer here? Okay, let's look at this, right? You have a limit if and only if the right side limit is equal to left side limit.
Negative 3.
And so are those the same thing?
Yes.
And what same thing are those two things?
Negative 3.
Negative 3. So in this case, our answer is negative 3. Now, remember that earlier when we went over homework, Kaylee and maybe others were talking about that's easier graphically to see what's going on. Let's go ahead and break this one down graphically. So you got x squared minus 4. So here's the graph like this. So what does x squared minus 4 look like? It looks like this. Comes down like this at minus 4, right? And then what does this negative 2x minus 1 look like?
Just like a line.
So it's a line that'll come like this. Okay, it comes down like this. So it comes down like this. And we find right here is what? Negative 3. How do we know that? Because it tells us from both sides where x equals 1, this is that. But I drew the whole function, right? And it's not that. What is it? Okay, here's your right side limit, right? So that means that all this business here is gone, isn't it? You see, I'm just leaving this piece on the right. And it also says greater than or equal. So we know this is filled in here. Okay, what about the other thing? Our left side limit is this one right here. So when we look at a graph of it, is this what the graph of it looks like? Yeah. And we know that it's filled in because we see that greater than or equal. What if it just said greater than instead?
There would be a hole.
Then there would be a hole.
It would just
Okay.
be not.
It would not exist at that value, but would the limit still exist?
Yes.
Yes, it would. Okay, so graphically, that's what it looks like. So I don't know if that's helpful to you, but there's a graphical equivalency for most of what we do, and that's it. So we're going to be switching between analytically and graphically and numerically, and I hope we get more and more comfortable doing that thing. Okay, this one right here, I want to do that one. This one here, I want to do this one, 22. So we have, I want you to work out 22 here. You have, what's left? When you see these things right here, I've called these things like in this case 3 is, I've called it a critical number, but it's sort of the number of evaluation. The x value, what do we consider that? Do you know, is Emily getting the videos?
Can I get this packet and I'll give it to her, or put it in my mailbox or something? Because
Yeah.
I feel like that would be helpful.
Yeah, it will be. Because I know she signed up for Remind, I know that. But, so this one right here? Yeah, I have it. Okay, on number 22, which one is the right side limit? The top one, right? So here's the right side limit, so I'm going to make an equal sign. And so I'm going to put x minus 1, and on the left side, that's our left side limit, so I'm going to put 2x minus 3. So what goes here in the place of x? 3. So we got 2 times 3 minus 3, and that's going to be equal to 3 minus 1. So we have, on the left side, we have 3 equals 2. Now remember, we have the limit exists if and only if the right side limit equals left side limit. Are these equal? Yeah, so limit as x approaches 3 of f of x, we will say does not exist. And it does not exist in this fashion. If we were having a fence here at x equals 3, here's at x equals 3, and from the right side, we're approaching 2, and I'm not even going to take into account what it looks like. We're approaching 2. Okay, we know that's filled in. And from the right side, we're approaching 3. So that's going to come up like this, and there's going to be a hole. So that's what the thing's going to look like, right? And that's that one. So go ahead and look at number 23. That should be a good one.
23?
23, yes.
How do you know in the piecewise equation, piecewise function, how do you know which one's left?
Okay, great. So Elizabeth asked the question, how do you know which one is left and which one's right? Answer for Elizabeth? Yeah, this one here, if it says x is greater than -1, whenever x is greater, that's the right side limit. If x is less than, that's the left side limit. So right side, and this one here is going to be left side. That's how you know.
Hey, Mr. G.
Yes.
So you know the, for Q, equation, we have to use synthetic division. How do we find that calculator?
Oh, the synthetic, how do you do that in the calculator for synthetic division? Well, to me, synthetic division is a non-calculator
I know that.
exercise. So I don't know how to reconcile you asking me to on a calculator thing that's not a calculator thing. I have a hard time conceptualizing what you're asking.
Because you want to know where it is on the calculator.
Yeah.
Oh, for the synthetic division on the calculator?
Yeah. So we've done it before. I just can't-
Oh, really?
I think it was in one of those. The synthetic division of the calculator.
Oh, yeah, we're just talking the numbers and
I remember you showing me.
Yeah, you showed us.
Something on a calculator?
Yeah, I think it was Emma that told us about it.
It wasn't in there, it was there.
No, I remember even in our class,
who showed us.
How to do synthetic division on a calculator?
Yeah, you just like typed in the numbers and it gave you.
Oh, I know what it was. It was was it the remainder theorem?
Yeah.
Yeah, in the remainder theorem, yeah, you type it in, but what you do is you just get the remainder. And if the remainder is 0, that means the thing is factorable. Okay, if it's not, so that's what you meant, I think. Yeah. But you still have to work it out to get what your quotient is. So that's it. So here's your left side is going to be 2x is going to be equal to, and I'm going to put a question mark here because I don't know that. And my right side is going to be x cubed minus 1. And now we plug in 1, right? So 2 times 1 equals 1 minus 1.
You have to plug in -1.
Is it -1? Oh, I'm sorry, I missed that. So 2 times -1, and then we have, well, that's going to be -1 minus 1, so that's going to be -2 equals -2.
Yeah, so it's -2.
So our answer to this is -2. Yeah, I had trouble seeing that. So what I have, that really brings us time-wise, we just have about a minute of class time left. And so I don't have I'm just kind of looking at this, 26, kind of looking where we go tomorrow. Okay, what we're going to do tomorrow is we're probably going to start with problem 26 here on what I call page 48 in my book. So we'll just go there tomorrow, okay? Thank you. Some good questions today. And that was a very good demonstration, Hannah. That was really great.